upon the point of explosion, the air is compressed and rarefied, compressed and rarefied, compressed and rarefied, compressed and rarefied until this fella's ears. Can't see the ear, I'll draw the ear for you. Oh, yeah. His ears. See that?
Yeah.
Yeah, so wing goes in. Okay, and therefore he gets to hear. Right? Alright, so we start with the what was the 2017 physics, combined physics paper. Okay, so get your calculator ready and we shall go through them right now. We will not care about what happened to the EMATs. 1 week to go, more than enough time to prepare for physics and chem. It's more than enough time. Okay, so we do this 2017 paper. You're going to watch the video again and again and again. Yeah, right. So as usual, I'll just keep doing.
Okay.
Yeah, I'll just keep doing, and as you go along, you got any input, you just let me know.
Okay.
Right? I'm just curious, right? The EMATS paper, was it like similar to 10 series?
Paper 2, not really.
Different, very different.
Quite different. There's only a few questions like the sector. The one where you find sector. That one was like similar.
Okay.
But other than that, not really.
Okay, never mind, right? Let's go. So anyway, let's take a look at this. So, car takes 60 minutes travel, 100 km along a main road, 30 minutes to travel, 20 km along a side road. So what's the average speed? So to find the average speed, formula for average speed, right, equals to distance divided by time. So we need to find the total distance. What's the total distance? 120, right?
120?
Yeah. Then there's 100 here, and then the other 20 over here. Okay? See that? 120. So a car, okay, what's the total time? 60 and
1 hour 30.
90 minutes, right? But we need to convert to, okay, it's 90 minutes. So we need to convert to hour. 90 minutes same as 1.5 hour. Okay? So 120 divided by 1.5, we will get 80 km per hour. Right? So the answer is C.
Yeah.
Okay, next. A car moving 40 km speeds up with constant acceleration of 3 minutes reaching a final speed. What's the distance traveled? Okay, so to find this question, driving speeds up acceleration final speed. What distance? Okay, let's try to draw a speed time graph.
Okay.
So the speed is time. So at first the car starts at 40 and then accelerate for 3 minutes, so it goes up to 80. Right, and then stop there. So the time taken is 3 minutes. 3 minutes. Now if this is a speed time graph and we want to find the distance traveled, where do we look for?
The gradient.
No, it's not the gradient. Gradient is the acceleration.
Isn't the gradient the distance, no?
No, the area.
Yeah.
It's the area, right? So to find the area, now this is something like this is a trapezium, correct? This thing is a trapezium. Can you see this thing?
Yeah.
Yeah, it's a trapezium. So we want to find the area of this object, right? So the area is okay. What you can do is, if you want, you can divide into a triangle and a rectangle. Let's say I want to find the rectangle, right? What's the area of the rectangle? It's 40 times 3. Right? 40, but here is 40, right? 40
times 3.
times 3. So it's 120. Hey, wait a minute. This one, okay, I need to change the time. to hour, 3/60. Because this is in terms of minutes, this 40 is hour. You see this hour? So I cannot use minute here.
You have to convert it.
Hour. So it's 3/60.
Yeah.
Okay. So 40 times 3/60 equals to 120 divided by 60. So it's 2.
2.
Right. So that is the 120 divided by 60. Yeah, that's 2. So that is the distance at the bottom. Then how about the triangle at the top?
Half base times
Yep. So it's half times 40 times 3/60 again.
Huh?
Right, the base here.
Yeah.
So 20 times, so it's 60/60 is 1.
1.
1. Yeah. So the total distance is 2
3.
plus 1 equals to 3. Alright.
Yeah.
Okay, which free body diagram shows the directions of the forces acting on a rocket traveling vertically upwards? So this thing is traveling vertically upwards. Should be C. Okay, so the rocket is traveling vertically upward. Thrust. Right, so the air resistance and the weight is pulling it down. Right? The weight of the rocket is pulling it down. Thrust is pushing it upwards. Okay? Hello?
Hello? It was a bit laggy, like you were.
Oh, okay, so let me just say again. The weight and the air resistance is just pulling it down. And thrust is pushing it upwards. Hello? Hello? Anybody there?
Hello?
Hello? Are you there? Hello?
Yeah, it's still a bit like I can like hear bits of what you're saying.
Can you hear me now?
Yeah, I can hear you now.
Okay, wait, I'll give it a minute.
Yeah, sure.
Okay, can you see this question?
Yeah, I can.
Okay, now this question, is it okay? It's actually quite straightforward. The thrust and the air resistance and the weight.
Yeah.
Okay, so I'm gonna move on, right? Next one. Okay.
How long is the day?
Okay, next one is here. So the mass of the stone is 4 and the density is 2. What's the volume? What's the formula for density?
Density equals mass over volume. So volume.
Mass over volume. So the mass is 4, right?
Yeah.
Density is 2. So the mass, the volume is V. How to find V? 4 divided by
2.
2. That will give me 2. Wait, the mass is 4 and the density is 2. What's the volume? What's the volume of
the
water?
minus the
Minus what?
stones.
Okay, yeah. So you see this? What's the reading here? 6, right?
1. Yeah, 6.
Yeah. So the volume of the stone is 2, right?
Yeah.
So it's just minus. Oops. Minus 2. So left with 2.6. Okay, answer is B.
Yeah, B.
Okay, next. An object is designed to topple over easily when hit. What should the object have so that it can topple easily? Now we want it to topple
High
easily.
center of gravity and narrow base.
Yeah, very good. Next. What is weight X? So this thing is its position by a 2 Newton force upwards. So we gotta find the clockwise moment. So what's the formula for moment?
Force times distance.
Yeah, so we take 4 times 4 equals to 16 Newton meter. Okay, so this is the clockwise moment.
Yeah.
Now how about the, is that all? Clockwise
No.
moment, is it? No, that's not all. Still got this one. Now look at this thing pointing upwards. So is this clockwise or anti-clockwise?
Anti.
No, it's clockwise.
Clock.
It's pointing upwards, so it's going this direction.
Yeah.
So it's very tricky, right? You gotta take 2 times
4.
the 4. So equals to 8 Newton meter. So you add together, actually it's 24. Right? So clockwise moment, it's 24 Newton meter. Now how about the anti-clockwise? So anti-clockwise moment. Now anti-clockwise moment is 2 times x. Correct? So 2x, now because the whole thing is balanced, so 2x equals to 24. So x must be equals to 12. That's is D.
Okay. Yeah.
Tricky, you gotta read properly. Right. Next, so that's 6 questions. Next one. Okay, so a circus act involves a performer lying on a large number of pointed nails. So there's no skin damage. Why? Magic.
Because.
Magic. Why? Okay, we can eliminate all this. This one, increase pressure, no, you see.
A.
Yeah, A is correct. Next. Assume no kinetic energy transfer. What is the minimum speed to enable it to reach point Y? What is the minimum speed?
Minimum speed.
Kinetic energy.
K equals half mv square.
Yeah, so let's try half mv squared. mgh. Okay, the kinetic energy here must equal to the mgh here, because it needs to go upwards, right? It needs to go upwards, right? So it needs to overcome this mgh. This is the half mv square. The half mv square must equal to the mgh. So let's try to find what is this mgh. So the mgh here is equals to m times, so the total height, g is 10, total height is 40 cm, so it's 0.4 meter. Right?
Yeah.
Yeah. So this is equals to 4m. Okay, the mgh here must be 4m. Now so this must be equal to half mv squared. Okay, can you see the algebra? So I need to find what is v. I can cancel both the m. So m gone. So I got 4 equals to half v squared. So times 2, 8 equals to v squared. So v equals to square root 8. Square root equals to 2.83. Right, so the answer for this is actually D. Is it alright?
Yeah.
You gotta do the reverse. Right? some algebra calculation. Okay, 9. Which statement is correct? The molecules are closer together than in the liquid. The molecules are much further. Cannot be B, right? It's wrong. It's also wrong.
C.
Yeah, C is correct. Next. Okay, blocks of gold are made
Hello?
by more. Yeah? 10.
Oh,
We look at 10. C is correct just now. So blocks of gold are made by pouring hot molten gold into molds. The gold cools to its melting point and begins solidify. As the gold solidifies, which statement is correct? Question number 10. The gold solidifies.
sure.
Wait, the gold cools to its melting point and begins to solidify. Now we are talking about as it's solidifying. That means we are looking.
So the temperature stays constant.
Yeah, we're looking at this part.
Okay.
Part. So it's either this or this, right?
C.
C is correct. Next. A wave passes along a spring. Which statement of a period of the wave is correct? Period. What is the meaning of period?
One oscillation.
One is the time taken. Right? So answer is D. This definition. Period means time taken for one full oscillation. Okay? This definition. Alright, next. In the human eye, there's a converging lens that produces image. Oh, okay. You gotta memorize this, right? 12 is A. This one must memorize.
The image at the back of the eye. Oh.
Yeah.
Wait, so which one is virtual? What would be virtual?
What is virtual? Which one is virtual? I think the magnifying glass.
Magnifying glass, camera, right?
No, camera is captured on the screen.
So it's not virtual.
Captured on the screen, right? Wait, let me double check.
Yeah.
Give me a minute. Waves. Okay, virtual is spotlight, magnifying glass. Yeah, just spotlight and magnifying glass. Hello?
Spotlight and magnifying glass.
Yeah, spotlight,
Virtuals,
magnifying. These are virtual. The rest are all real.
So camera is considered real.
Yeah.
Okay.
Because it can be captured on the screen. Spotlight magnifying glass cannot be captured on the screen. Spotlight cannot because it's just one. There's no fixed focus. Magnifying glass because it's reverse. It's on the other side. Okay. So, right. This you can look at the notes.
Yeah.
Comparative guide to physics, right? Then you can see. Okay. Okay. Next. So you see the first 10 questions, right? I think it's quite okay. Only here a bit shaky already. Right. What is the use of infrared radiation? So this is like a
the grammar X.
Yeah. Infrared. What is infrared used for?
The sterilizing. No, that's gamma ray.
Mm.
The checking metal
No. Is this one?
alarm detect.
13. B. Intruder alarms. You know the infrared? The thief touch the infrared
Okay.
alarm, the alarm will ring.
Yeah.
That one, okay? Next. What's the order for speed of sound in air, steel, and water? So sound is fastest in solid, right? Sound is fastest in solid, followed by liquid and gas. So answer is B.
Well, I'm going to use the toilet for a while.
Yeah, go ahead.
Hello?
Hi.
Yeah.
Okay, let's continue. Shall we continue?
Yeah.
Alrighty. So this one okay? The speed of sound in air, steel, and water. Steel is solid, right? So solid is the fastest.
Yeah.
Okay, can. Next. Continue. So ship sends a short pulse frequency, blah blah blah. What's the depth? Okay, the speed of sound is 1005 meters per second. Okay, so there's an echo, right? 2.4. So DST triangle, right? ST. So to find the distance, to find D, what do we do? To find D, you must take speed times time. So we have the speed, we have the time, right? Hello,
Hello?
are you there?
Yeah.
Yeah, so we take speed times time. Can you see the speed times time? Speed times time. Hello? Hello?
It's a bit laggy again, like it's like chopping.
Chopping. Laggy. Can you see the 360?
Yeah, I can.
Can, okay, so 360. So it's 1005 times, because we take speed is 1005, time is 0.24, right? So you multiply, we get 360 meter. But you must remember this is echo. So you gotta divide by 2.
2.
So it's 180. So the answer is A. Okay? Okay? Move on.
Yeah.
So far, okay, right?
Yeah, so far it's okay.
Actually, it's quite okay. This is your favorite. Which statement defines the direction of field lines due to a point charge? Can you do this? It's your favorite. Come. Is this your job? It's your job. Okay. I got the answer, right? Answer is D.
D.
Yeah, so you can study why, right? Next. Okay, to fully charge a battery, a current of 0.3, 3 is used for 5 hours. How much charge? So formula time. I equal Q over T. So Q equal to IT. So must take the current times time. So current is 3. What do we do with the time? Time, is it 5 hours?
No, convert it to minutes.
Minutes,
seconds.
Yeah, 5 times 60 times 60. Right? So 515 times 60 times 60 equals to 54,000. So the answer is D. Right? D is the answer. Next. 18. What are the values V and IT? Okay, V and IT. Alright. So V is the voltage. Voltage V EPT. Now to find voltage, I must take current times resistance, right? Correct?
Yeah.
So the current here is 3 and the resistance is 3. So 3 times 3 equals to 9.
9.
So this one 9 volt. Okay, so it's either this or this. Can?
Yeah.
Next, must find the current. So the current cannot be 3. Answer straight away B. Why cannot be 3?
Because
here is already
3.
This is already 3. Right? This one is equal to 3 plus the current here. You see that? Because the current coming will split. Current that comes in is going to split into 2. Correct? So there must be some value here, right? It cannot be 0.
Yeah.
Right? So if it's not 0, it cannot be 3. So this is definitely wrong. Answer is B. You don't have to do extensive calculation for this. Right, they'll save you some time. Next. 19. So a plug for a lamp contains a fuse with 3A. Which statement is correct? 19. Answer is A. The fuse breaks circuit with the characteristic 3. That's the purpose of the fuse.
Yeah.
Okay, next. Oh, this is your favorite again. How many of the 4 directions shown can the force act on the wire? So, question 20, last one. Just tell you the answer. It says B.
True.
Why? Because you must use Fleming left-hand rule to deduce the direction of force. And the induced force must be perpendicular to the direction of the magnetic field. With any possible combination of magnetic field and current, there are only 2 possible directions of force. Alright, that's what the answer says. So please go ahead and study this, right? So let's say if you give up, if it was me, I will give up 2 questions, I will still score 18. Okay? Right, life is good, LG, okay? LG, you watch LG TV?
No.
You not fan of LG?
I use
what's
that?
Samsung.
Samsung, yeah.
Oh man, I LG fan. Life is good. Okay, so we continue, right? Any questions so far, MCQ?
No.
No. Okay. Okay, let's move on. All right, complete the following sentence. Oh, this English close passage here. Complete the following sentence. Vernier calipers may be used to measure to the nearest how many mm?
0.1.
Yeah, that's great. Right, 0.1 mm. It gives such a big space. Right. The barrel and the thimble of a micrometer screw gauge are shown. Record the reading. Okay, what reading is this? So we see this is 5, right? This is 6. This one is 7. Okay, and this one is 6.5. So this also hits 7.5. Alright, so it crosses 7.5.
Plus
So,
0.24.
yeah, awesome. So you plus 0.24, 7.7.
4.
Okay. Alright.
Yeah.
Awesome. It's 2 marks. Oh no. F is a focus. 3 rays ABC are drawn. What are you supposed to do? Complete the ray to locate the image. Draw an arrow to represent the image. Okay, pink color. Okay, so the object is here. We got this one come here. Now because we have the F. Okay, let's highlight the things that's going to help us, right? See the F here? Right, you see the object here? You see this line?
Yeah.
Okay, so let's try to draw that line first. Okay, I'm going to use the straight line tool. So I will get a straight line. Yes, it's a straight line. See, draw freehand or no? Powerful. Okay, so one light ray pass through there, right? Where is the other one? Another one here. Okay, somewhere here. Oops. From here. Okay. So yeah, that's about it. Okay, so the arrow is like this, right? Remember, you must have one that always pass through the first focal length. Yeah. So where's the image? It's here. Is over here. Okay. Is that right?
Yeah.
So draw an arrow represent. Use the completed to determine. Okay, this one you must measure, right? I don't know how to. I mean, I can't measure. It's not to scale. You measure the thing, you get 38 cm. Magnification. Measure the thing. It says that this is 10.5. Measure is 7.
Yeah.
So you take 10.5 divided by 7 is about 1.5. So the magnification is about 1.5 times. Right? That means you have to physically measure this one and this one. Right? So this is 10.5 and this is 7. Okay? Next. I think this is like the second time I've seen this type of question.
Yeah.
So I don't know if it will come out a third time. So anyway, did the school prediction come true?
Yeah, it did.
Not really useful. Okay. Okay, next, the object is now moved so that it's 10 cm from the lens. Describe 3 characteristics of the new image form. Now it's 10 cm. Okay, I have no idea where it's 10 cm. I think it's moved closer. Yeah, you see this is 25, right? So now they move closer. Move inside. So when you move inside, it's now closer to the focal length. You need to determine exactly where it is in the focal length. So because it becomes less than f. Less than f, you're gonna memorize. Okay, looks like you really gonna memorize that thing, you know. Remember all the converging lens thing?
Yeah.
Right? Got a lot of it. So the image is virtual. It's upright, right, and it's magnified. Okay, you gotta memorize the characteristic. If not, you can try and draw on the spot. Okay? But I think they drew for you, right? Did they draw for you? No, they did not.
Yeah.
Okay, next. Okay, calculate the. Sorry? What's our question?
Oh, I didn't say anything.
Oh, okay. So a gold bar weight 125. So formula W equals to mg, right? First one, they ask for the mass. So the mass is here, but my weight is 125 times 10. So m is equal to 125 over 10 equals to 12.5. Now this is 12.5 kilogram. So I need to convert this to grams. Gotta multiply by 1,000. So 12.5 times 1,000. It will be equal to 12500 grams. Okay? Is that right?
Yeah.
Okay, volume, length times breadth times height. So 4.3 times 6 times 25. That would be 645 cm cube. Next. Use your answer current density. So density equals to mass over volume. So the mass is 12500 divided by volume of 645. That's 19. Right? Oh, giveaway mark. 5 marks free. Yeah.
Oh.
Yeah. 5 marks, huh? Free. Next. Density. Next, pressure. So the bar can be turned so that one of its face is contact. Calculate the least pressure. So to find the least pressure, you gotta find the biggest area. You see the blue color portion is the biggest area. So what's the area? 6 times 25. Right? So pressure formula F over A. So F, what is the force? Force is here, right? 125.
Yeah.
So 125 divided by, what was it? 6 times 25. 6 times 25. Use your calculator, you get 0.83. Okay? Free 7 marks. 7 marks. Plus just now 5 marks. Right? So formula save the day. Next. Okay, so there are some statements about electromagnetic waves, some are true and false. Complete all of that. First, infrared waves are used in TV remote. True or false?
True.
True, yeah. Next, all electromagnetic waves have the same frequency in air.
True.
False, different frequency, different wavelength. What? There are different wavelengths, so different frequency.
Oh,
right? Radio waves are used to transmit satellite
true.
television signal. Yeah, that's true. UV have shorter wavelength. True.
True.
Okay, must memorize. All electromagnetic waves have vibration and molecular.
True.
Yeah. All travel at the speed in vacuum. 3 times 10 to the power 8 kilometer per second.
False.
False. Why? What's wrong?
Because it's not 3 times 10 to the power 8.
Wrong. It's not kilometer. It's meter.
Okay.
It's meter per second. Gamma rays have the longest.
False.
Because it's the reverse. It's the shortest.
Yeah.
X
Uses Viagra in
Viagra in
room.
Right, this one is the shortest. This is the longest. Okay, last one. See, your light increases as it passes from glass to air. True. Okay. Right, so this one, there's the electromagnetic spectrum. Okay, so calculate for the first 6 seconds the distance traveled. So take note, speed, time, distance is the
Gradient.
area.
Area.
Right? It's the area. We need the area. So first 6 seconds. Where is the first 6 seconds? Let's highlight this. Okay, this is my super straight line technique. Here. Oh no. Okay, can you see that's the first 6 seconds? First 6 seconds. Okay, so I need the area under that part. What is the what is the speed? When the what? 7, right?
20. I can't really see.
27.
Okay.
So that's 27. To find the area under this, I gotta take half time. Raise. Wow. Professional. Okay, how to find the area?
You take half
Times
6
times.
27.
Yep. So that will give me 81.
Yeah.
Right, so distance travel 81. Next question, acceleration. Okay, acceleration is the one that you keep saying. How to find acceleration?
The gradient.
Yeah, so to find gradient, rise over run. So the rise is 27, the run is 6. Right, so 27 divided by 6 using calculator. Calculator says 4.5 meter per second square. Okay? Right, next, use your answer to show that the resultant force is 5.4 kN. Formula for resultant force, F equal what?
ME.
Yeah, so do I have the mass? What's the mass? Oh, okay, see the mass? 1.2 times 10 to the power 3. 1.2 times 10 to the power 3. The A, this is the A, 4.5. What do we get? Okay, we get 5.4 times 10 to the power 3, which is the same as 5.4 kN, right? Okay, so it's correct. So calculate work done. What's formula for work done?
Work done equals
Force times what?
force times distance.
Yeah, so force is 5.4 times 10 to the power 3. Now what's the distance it traveled? See here?
81.
So 5 times 81. So work done, calculator, press 4.4 times 10 to the power 5 joules. Okay, see that? These are all formula. Please memorize formula. Okay, we use formula. Formula will save your life.
Yeah.
Thanks. Okay, explain how the stability of bars is improved by having a wider base. So I love this type of question. This one will this side is also give away, right? So why is it that when you have a wider base, so a wider base, the bars
The center of gravity is
no, not center of gravity, greater base area, right?
more surface.
Yeah, because where is the center of gravity? Maybe somewhere here.
Yeah.
As long as it's between the base, it will be stable. So what if it's made of thicker glass? So when it's made of thicker glass, you see this area, it's heavier. So
Yeah.
it brings the center of gravity downwards. See that?
Yeah.
So a base of thicker glass increases. Sorry, what is it? D brings the center of gravity lower. Okay, so two things about stability. As long as the base is bigger base and a lower center of gravity, it will be stable. Right? 2 marks. Say thank you to that. Yes. Thank you, Cambridge. Next. Okay, formula again. So we have a circuit containing 4 resistors WXYZ, battery 12 volt, blah blah blah. First one, name 2 resistors that have the same current. Same current. Okay. It should be Z and W.
W, yeah.
Why?
Because
It's the same loop.
it's what?
It's in one loop. Do you understand why?
Yeah, because the
It's one loop. So for current, right? I equal I1 equal I2. Right?
Yeah.
Okay, so this is a series. These two are series. So the current will be the same. Part 2. So name 2 resistors that have the same potential difference across them. Which one have the same potential? That means voltage. V equal V1 equal V2, right? So we look for parallel. This one and this one. So X and Y. So far, okay?
Yeah.
You done this how many times?
Many.
So you memorize answer.
Yeah.
But you must understand why. Alright, so show that the total resistance is 15.
They use the
Formula, right?
yeah.
Okay, what's the formula for resistance? 1 over RT equal 1 over R1 plus 1 over R2. For series, RT equals R2. Alright, so you gotta memorize this, and total resistance is 15. Okay, so first we gotta calculate this one. 1 over RT equals 1 over 6 plus 1 over 3. Combine them. So RT, so this equals to 3 over 6. So you got to reverse it, inverse. So RT equals to 2. Alright? So that means the total resistance here is 2 kilo ohm. Alright? Now we want to add them together. Now when we add them together, they are considered series. So we take 7 plus 2 plus 6. Right?
Yeah.
So 7 plus 2 plus 6 kilo ohm. Next. Calculate the current in resistor W. Resistor W. Okay, so to find the current in resistor W, we gotta look at the current that is flowing in the entire circuit. So to find current, V equal IR. I equal V over
R.
R. So our V is 12, our R is 15. So I equal V over R, 12 over 15. Right? So what's 12 divided by 15? Hey, wait, error. It's 15,000.
So you have to convert it.
Yeah, because it's K,
Yeah.
1, 2, 3. So 15,000, right? So 8 times 10 to the power minus 4. Right? Then next, calculate the PD across resistor Z. So where's resistor Z? Z is, where is Z?
7 ohm.
Yeah,
7
so what is PD?
potential difference.
Yeah, we also want to find voltage.
Yeah.
Okay, now this is the series, right? So voltage V equal to V1 plus V2. Right? But actually we don't have to use this formula. To calculate voltage, use this one. V equal IR. Because we know the current. See the current. So V equal IR equals to 8 times 10 to the power minus 4 times 7,000. Right, and we will get 5.6 volt. Okay?
Yeah.
So, yeah, so you see this paper 2 portion, a lot of formulas. Make sure your formula is good. Right, state what is meant by electric field. Oh man, this is your favorite.
Oh,
What's electric field?
in electric field,
Yeah, is
region where
a charge.
experiences a force.
Yeah.
Yeah.
Okay, isolated negative point. So this is minus. Minus means all go inside.
Yeah.
Okay, so arrow. Arrow in. Well, this 2 marks, no?
Just like that.
Yeah. Better draw properly.
Yeah.
Okay, arrow in. Okay? Make them happy, right? X. Okay, find the charge passing through the lens. Formula for charge. Q equal to
IT.
Yeah, so where's I? 2.5. Where's T? It's 5 minutes. So 2.5 times 5 times 60. 750 coulomb. Energy delivered PT, right? IVIR. Right. So to find the energy, I need the power times time. Do I have the power? No. So power equals to current time voltage.
Yep.
So P equals to I V 6. 2.5 times 6, which is equals to 2.5 times 6. 15 watts. Then P times T. So 15 times 5 minutes is 5 times 60. So what are you following?
Yeah.
Yeah, so it's 4,500 joules, right? So formulas, physics is all about formulas. Okay? Formulas. Formulas, right? So please memorize all your formulas. Next. Oops. Okay, section B. Okay, this is about the heat. So we got this black color, this one is silver. Describe how the thermal energy passes through the walls of the cans. Very good. It's vibration. Because the wall of the can is conduction, right?
Yeah.
So you gotta describe the conduction process. What's the conduction process? From hot to cold. Vibration of the particles pass the vibration from one to the other. Okay? So I'm not gonna write the whole thing here. Why it cannot be conducted effectively through air? Because the particles are far apart. Right? So because the particles are far apart, you want to vibrate your neighbor, you cannot touch your neighbor.
Yeah.
Right, next. Okay, draw to show the temperature in can A. So can A, this is can B. So can A is silver. Can B is black, dark and black. That means can A is going to be slightly later. Right?
Mm-hmm.
So it's just slower. Okay, you see the curve? Slower.
Yeah.
Next. Explain any difference between the shade. So what's the difference? We say that can A is gentler. Why? Because it's shiny. What's so different about shiny? Absorb slower. Right? Can you see that? Can you see that the shiny one is going to absorb the heat slower?
Yeah.
Alright, that's fine. So this is fine. Describe how motion and arrangement of molecules change as the wax is heated. So wax is solid, right? Heated become liquid, right? So you gotta describe the process. Okay, so solid they are fixed, vibrating about fixed position, right? So you gotta when it's being heated, what happens? Gain kinetic energy, start to vibrate more, right? Then after that, it will break the bonds and become liquid. So when it's liquid, it start to slide against
Each other.
each other. So is it still in a fixed position? No more. So what type? What? They are like random, moving at random motion. So you gotta talk a lot because it's 4 marks. See that?
But how do
Yeah.
you like talk a lot?
Just describe everything lah.
Uh,
Describe all everything that you can remember. Right? Just lump it, put it down. It's like it's I'm asking you how does your spectacle look like? What do you say?
it is round with
Black.
black.
Yeah. So but if I say I want you to say more, I'm gonna give you 4 marks. What do you do? Talk more lah, right? It's round, it's black, but the round is not exactly round. It's oval shape. It's straight at the top. It's like angle 45 degrees.
Just sort of talk nonsense.
No nonsense. What the no. We record this one. No anyhow say. No nonsense. Okay. Right. We say the truth and the facts. You gotta dig into your head to write all the facts. Right. Can? Yeah. Go ahead. Just describe in detail. Exactly what. Okay, so far up to here is pretty alright. I think it's pretty alright. We are scoring marks along the way. Just some stuff that we give up. Alright. Next, we do one more, right? And then we can go and sleep. Calculate the time taken for the sound to travel from the teacher to the student. So this is DST triangle. You gotta use the DST triangle. We want to find the time. So time is distance divided by time. So distance is 100 meters. So 100 divided by. Anyway, we want to find the time. We need to take distance divided by speed. Speed is 330. Alright, so we get about 0.30. Okay? Right?
Yeah.
Okay, 0.3 seconds. Explain why the time recorded is likely to be very inaccurate.
Because the distance between the teacher and the student
Too short. Teacher too short, right? Distance too short. Distance too short.
No, but won't the time then be more accurate if it's shorter?
No, because the error will be bigger.
I thought if it's further away, the error would be bigger.
No, because so the duration, you see, they are trying to raise his arm and hear the sound. The difference will be very little. So because the difference is so little, how do you record 0.3 seconds? Like how can you figure out 0.3 seconds? How fast is 0.3 seconds?
Super fast.
Like you blink your eyes is already 0.3 seconds, right?
Yeah.
What if this fella raised his hand and then he blinked his eyes, and then the sound already come here. So what if it becomes 0.4 seconds? It's already how much, 30% off,
30%.
Yeah, because the time is too short. So a small error would appear very big. One more time. The time is too short. A small error would appear very big. That's the explanation. One small error will appear very big.
So if it's a
Further,
a larger amount of time, the error would be
smaller.
Okay.
Let's say if it takes 5 seconds, and then you make an error of 0.2 second, right?
Yeah.
It's not a big deal. But over here, if you make an error of 0.2 second, basically the whole experiment is wrong. Versus 5 seconds, right?
Yeah.
Yeah, it's like if you got $5, you throw away 20 cents, are you heart pain?
No.
You feel no. If you have only 30 cents, then you throw away 20 cents.
Okay.
Heart very pain, right?
Yeah.
Yeah, it's like, oh my god, I only have 30 cents. Now I only have 10 cents. Okay, next. So that's the idea. Okay, next. Okay, two students A and B do an experiment. Go at time taken. Wow, this too lengthy lah. You see the word? See the words? Too much story.
Yeah.
End up we are spending time reading the story. Okay, but we gotta do it anyway. So, two students A and B compare the time for sound to travel through rock and air and sand equal distance. What are they doing, man? From a small explosive placed at the ground as shown. This person died already. This one hide behind the post. This one the explosive shoot this fella. Why? Okay. So the distance between the explosive and the student is 1 kilometer. So it set off time. But against the post that stuck into the ground. Yeah, okay. Do you get it? Basically, you don't have to read the whole story. Why? Because you look at part 1. Describe how the sound travels from the air to student B. What kind of way?
What's there? Trends?
What?
Transverse wave.
You sure or not?
Isn't transverse wave the
Transverse is...
so it's longitudinal.
Yeah, so it's longitudinal. Okay, longitudinal, what is the characteristic? Compression and what?
Fraction.
Right? So here you got to describe, right? So we say that upon the point of explosion, the air is compressed and rarefied. Compressed and rarefied. Compressed and rarefied. Compressed and refract until this fella's ears. Can't see the ear. I'll draw the ear for you. Oh, here. His ears. See that?
Yeah.
Yeah, so wing goes in. Okay, and therefore he gets to hear. Right? But of course, you just talked about this kind already. But let's see how many marks it is. How many marks?
4, I think.
Huh? 4 marks? 2 lah. 2 lah.
Oh, 2.
Yeah, 2 enough. But if they talk about, if they give you 4 marks,
Yeah.
you gotta go in, go into the ear. What's inside the ear? The little bone.
Bone.
Yeah, ear bone. Ear bone. Right? So the ear bone vibrate, correct? Ear bone vibrate, send signal to where? To the fella's brain. His brain is here. Right? Okay, that will detect the signal.
Yeah.
Okay, but his brain a bit small, you see. His head so big. Brain too small. I must draw bigger. Okay, just kidding. Right. So anyway, you get the idea. Compression and rarefaction. Vibration of the air particle passes the sound all the way to his ears here. Okay. Okay. Next. Explain why time measured by student A is less than the time by B. Time by A is time by B. Do you know what they are measuring? They are measuring the time taken to hear the sound. So explosion here to right, it goes here. Now, first we need to understand that person A didn't die, right? She is still alive, even though the way they put it,
It looks like this.
yeah, it's like she's dying, and then the other one is like covered behind the shoe. No, right? So the person never died. So what person A is hearing is, can you see that she's putting her ear towards the post?
Yeah.
You see the ear? You can see the ear? Draw, right? So the ears is here. It's stuck to the pole. This is the pole. Okay, so she's hearing the vibration from where?
From the ground.
From the pole. Now, yeah, from the pole. So where does the vibration come from?
The ground.
Yeah, from the ground, right? So it comes from the ground. So who is going to hear it first? So the question is saying, how come this person A hears it first?
Because she...
Sound. Because sound travels what? Faster through what?
Solid.
Very good. That's the gist of the thing, right? Sound travel faster through solids, right? So why does it travel faster through solid? Molecules in the rock. Okay, how many marks? 3 marks. So we give them face. Must say a bit more. Right. Molecules in the rock are close together, right? Closely packed. Right? Now because they are closely packed, vibrations, what happens to the vibrations? Can they be passed faster? Hello? Hello? The vibrations are passed. Hello, are you there?
Yeah.
So the vibrations are passed faster because they are next to each other, right? As compared to this person B, okay, this person B must wait for the particles to vibrate to the air and then to his or her ear. Her ear disappear. Her ear is here, right? earring. Right? So it takes time. So it's slower if it's through. Why is it slower through the air? Why is it slower through the air? Because the particles are further apart.
Okay.
So in the air, molecules further apart, right? So cannot pass vibrations as fast as solids. Okay, hence person A will get it first. Is that
Okay.
right?
Yeah.
That's it. Okay, so we will stop here for today. We still have question number 12. Where is question 12? Okay, question 12. Wow, this looks so difficult.
This one is
Easier.
quite hard.
Quite hard. Wait, do you get a choice here?
Yeah, you do.
Oh, then finish. Just choose the first two, right? Choose any two. So we are done with two.
Yay.
Yay! So 2017. Alright, this one, actually this is quite okay. One calculation plus two. Wow, this looks difficult. Input energy, water flow. The one, right? This one easier. This one easier, right? Is this easier?
Yeah, that one is easier.
Yeah. Alright, just nice. So we end here for today. Please continue to watch the video. Watch the 2018 one as well. We will do, let's see, what other time? Meeting you tomorrow again, right?
Yeah.
Yeah, tomorrow. Then we can do Skype again. So tomorrow you want chemistry or physics?
I think. I don't know. I think can try chemistry.
Or you want to do maths? You want to do maths? Do e-maths. Just kidding, right? We do chemistry, okay? So I'll go ahead and print the 2018, is it? Did we do the 2018 paper?
For chemistry?
Yeah.
I think we did. But we didn't do on the Skype.
Oh, okay. Then we do Skype, so you can record and you can watch over the weekend.
Okay.
Alright. Okay, so see you tomorrow.
Okay.
Okay, bye.
Bye-bye.
Bye. See you.